We'll see about tangential and angular velocity. Now you can see here, consider this, the bicycle wheel is just about this axis, it rotates. You can see here, it will follow a rotational path. You see, just displaced all these distances. Now, when you are just considering this case, you can see here that you see here is just the angle should be just subtended. Now, as we defined earlier, we can see that the angular velocity omega is just denoted by delta theta over delta t. You have this value. And earlier we defined that delta theta is equal to delta s over r. This value is just defined. When you just substitute this value somewhere here, we can see here that delta theta is delta s over r divided by delta t. This is just the same as delta s over r times delta t. You can have this. This is just equivalent to 1 over r times delta s over delta t. Don't forget that from linear motion we define this quantity as the average velocity, v. So we can write omega is equal to v over r is just exists here, where omega is angular velocity, v is tangential velocity. So angular velocity can be represented by the ratio of the tangential velocity and the radius vector. You can see here around this path, when a particle is just moving about this axis at a distance r, the particle is just exists. It can move like this one. This velocity is known as tangential velocity. The tangential velocity is always perpendicular to the radius vector, and it is just acting always tangent to the circle. So we can simplify v is equal to omega times r can be just the expression for this physical quantity. So we may have here 1 and 2. Earlier we defined this physical quantity as the third one. So we have 1, 2, 3. Sometimes one can express omega is equal to as delta theta over delta t. For one complete motion, delta theta is equal to 2 pi rad. And the time delta t is equals to period. Therefore, what will happen? Omega is equal to delta theta is 2 pi over period. This expression is just also used to find the angular velocity. This is the fourth expression. One can find from wave theory 1 over the period. This is equals to a physical quantity called frequency. So we can write omega is equal to 2 pi times, in place of 1 over t, you can have here f. So one can express here that 2 pi. This is just also the fifth expression for this physical quantity. So in general, we can get all these physical quantities when we are talking about angular velocity. Now let's see example here. What is the tangential velocity of a body? What is the tangential velocity of a body? rotating in a circle of radius 50 centimeters with an angular velocity of 30 rad per second. As you go back through the solution to this problem, we can have here, we defined earlier omega is equal to V over R. And V is equal to omega times R. Thus, V is equal to omega is 30 rad per second times, in place of this 50 centimeter, we can have that 0.5 meter. This is 0.5 meter. So V becomes 0.5 times 30 is 15 rad per second. So the answer is just gone to choice A. Consider the figure shown here. Which point has a largest tangential acceleration? When you are talking about tangential acceleration, we must have to know first the tangential velocity. Which point is just more suitable to have a high tangential velocity? If there is a high tangential velocity, which is just denoted by V, one can find here, this point has VB, this point has VC, this about this axis, this is VC, VA, and this is VC, and this is VD. You see all these points. Now here, you can take that, VB, the tangential velocity at point VB, V is equal to, since V is equal to omega times R. As R increases, the tangential velocity increases. So VB is equal to omega times RB. The same thing, VA is omega times RA. The same thing here, VC is equal to omega times RC. VD is equal to omega times RD. You see here? As a result, what will happen? Since RD is greater than RC, greater than RB, greater than RA, and greater than RB, then what can you say here? We can take here that the value of the tangential velocity at point D is greater than all this. So at point D, this value is just the largest one. Because as R increases, the tangential velocity increases. As R decreases, the tangential velocity decreases. So the answer is just gone to D. When you are talking about uniformly accelerated circular motion, always we must have to know that there must be what is known as there must be an angular acceleration, which should be just verified. Now, in our next lesson, we'll consider about such a physical quantity.